This is the final part of our data analytics project, and in this video we'll build the Power BI data model and the DAX measures. If you haven't watched the first two videos, make sure to see the links below with the steps we have taken so far. This Power BI file is available on GitHub and you can download it from there if you want to follow along. Link will be in the description below. So when you open Power Query, you will see that there are two parameters. The first one is pointing to a data extracts folder, and you should update this with this location on your machine. This folder, as we've seen on video 1, contains all the data we have exported from the API. So you should end up with something that looks like this, where you have a file per journey, per date, and per hour. So if I open one of those up, it should look like this, a JSON file that matches that criteria, one for each journey. The second parameter is the station's data source. And this is a spreadsheet which you will also find on GitHub that lists all the train stations in the UK, its name, the station code, and their location. However, to keep the data volumes down, we are only looking at West Coast Mainline, and that is this last column. We are just looking at 31 of those stations that I have flagged here on the right hand side. In terms of the dimensions table, it is pretty straightforward. So we are reading the stations just mentioned a second ago, and the only thing we're doing here is processing the data so that we have these location fields, which will come handy when presenting data in a map. And then station from and station to are just referencing that first dimension, and we do this for the purpose of the data model, which we'll get to in a second as well. In terms of the fact tables, we will read all the files inside the data extracts folder, which is this one we just saw a second ago, and we will extract all those JSON files in one go by reading the whole folder. So at this stage, each row represents a journey between two stations for a given day. Here to the right, we have added a schedule key, and this tells us of a train service between two stations for a given hour regardless of the day. So you can think of it as a journey ID. And we use that in the next auxiliary query where we count how many trains have run for a particular schedule key. And then we remove services with very little utilization to avoid skewing the data. So this might be because of a special service that only run a few times for exceptional reasons. And then finally, in this last query, which is the one we do load into the model, we just add a rank column, which is this one here, and that will come handy as we will see in a second. The data model is a simple one and consists of our two-dimension tables connected to the fact table by station code. We have two-dimension tables because if you look back into the main page, we want the user to be able to select a station from and a station to, that both should filter our data. So this could have been potentially achieved just with one dimension table and with two relationships, one of them being inactive and then activated through DAX. But as the model is small, this solution is potentially the easiest to understand. As mentioned in the last video, today we'll see how to build this paginated table to display the probability of trains being late. As you can see in this table, the contents are controlled by the slicer at the bottom, rather than the usual scroll bar you would have with a native table. This is because on this specific case, we have built visual elements to simulate an LED screen, and a scroll bar would not work in this situation. I'll now switch to a demo file and I'll explain how we can achieve this behavior. This is a simple test dataset with two groups, alpha and beta. So for group alpha, we have 10 items ranked 1 through 10, and for beta, we have 5 items ranked 1 through 5. So very simple. What we want here is to add a measure to the table that will tell us what page each row should show on. So for example, if we want to show 2 items per page, row 1 and 2 would be in page 1, row 3 and 4 would be in page 2, and so on and so forth. So we'll start by adding a new measure, and we will specify how many items we want to show per page. So that will be as simple as calling it max items per page. And for now, for this test, we'll say we want 2 items. Next, we need to know what is the first rank we have on the table. And bear in mind, this needs to be dynamic. So what I mean by that is if I have a rank slicer here, like so, if the user interacts with the slicer, now the first rank is 5. Or if the selection is like so, the first rank is 2. So we need a measure that tells us for each scenario what is the first selected rank. So I'm just gonna create a new measure and we'll see how to achieve that. And we'll call this test as this measure is temporary. So we simply want to calculate the minimum or the first rank for all the selected data. So that will respond to the user selection. So if we test this measure, let's see what we get. So in this case, the earliest rank or the first rank is 1, but if I select a different one with a slicer, and now it's dynamically telling me the first one is 5, or in this case, the first one is 9. So that is working as we intended. Now we need a way to see what rank is being evaluated for each row of the table. So that should be pretty easy if we add a new measure that simply goes row by row and understands what rank it belongs to. And that can be achieved just by using the max function or even sum. It doesn't really matter because that's going to be evaluated for each row of the table. So I'm going to call this tests current rank and we'll add this to the table as well. And it should give us the rank for the current row. If you remove those filters, then it is the same as the rank as intended. Now with these two test measures, we can do a calculation that will bring us very close to what the page number is for each of these rows. So let's add a new measure and I'll call this page number calculation. And if we do the current rank less the minimum selected rank divided by the maximum number of pages, we'll see what result we get. So I'll bring that to the table as well. Right, and the first problem we have here is that the first row is showing page 0, so we can't have that. So we're going to simply add 1 plus 1 to this calculation. And that's starting to get a bit closer to what the pages are. So remember, row 1 should be on page 1, row 2 should also be on page 1. So if we round these numbers down, we have our answer. So let's come back to the DAX measure and round everything down. And right now, this is the result we wanted. First two rows on page 1, row 3 and 4 on page 2, so on and so forth. What happens now if we change the maximum number of items? Instead of 2, let's say we want 3 items per page. So we should see that the first 3 rows are on page 1, the next 3 are on page 2. Let's see if that happens. And here we have it, exactly as intended. Now, this needs to remain dynamic. Let's say we remove first a few items from the selection. Now the first 3 items on the table go to page 1, the next 3 go to page 2. So this is exactly dynamic as we wanted. Alright, so now we can simply clean this up. We don't need these test measures anymore. We can bring it all together on measure number 2. So what I will do is replace this right here with all of that. And if we use variables to replace these test measures, we can have it all in one function. So I'll do that. And the end result should be the same, but we can now remove these test measures from here. So I'll go ahead and do that. At this stage, we need to add a parameter to the page that will allow us to select what page we want to see. And we can do that here on the modeling menu by adding a new parameter. We shall start at 1 in increments of 1, and we'll make this dynamic in a second. So for now, I'll go ahead with this. And if we turn this into a list and then into an horizontal slicer, this will start making it a bit more obvious that we can select pages through here. So at the moment we have too many pages, and we'll make it dynamic in a second. So by default, a measure was also created called parameter value that tells me what is the selection of the parameter. So I will instead call this selected page. And if we drop it on a card just to see what this is doing, we can see that will tell us what page is selected on the parameter, but it does not yet affect our table. So that's what we have to do next. We need to create a measure that recognizes what page is selected and filter the table accordingly. So let's add a new measure here. And if we call it flag selected page, we basically want to see if the page calculation we have for each row matches the selected page, which comes from the parameter. So let's see what this tells us. If we add this to the table, so now we can see we have page 2 selected, and this flag is telling us that indeed everything on page 2 is being flagged up as true, which is exactly what we want. And if we switch to page 1, then this dynamically tells us that everything on page 1 is flagged up as true. So this is great. However, if we try to filter the table using this flag, we cannot open. Power BI doesn't let us open this and do any filtering with it. So what we have to do is to transform these true and falses from a boolean to an integer, so a number, ones and zeros. And we can achieve that very easily just by adding this int, which means integer, and replicating the exact same calculation. And now we have it. Ones mean true, 0 means false. If I change to page 2, this will again dynamically update accordingly. So now it's very easy to update the filtering on the table. Let's say that we only ever want to see data when the flag is 1. And at this stage, it is important to remove the flags and the calculated columns because the context will change, but everything will work fine without being on the table as we expect. So if we look at page 1 and we remove this rank right here, we should expect to see the first 3 items. And there we have it, 1, 2, 3. And on page 2, items 4 to 6. And there we have it, 4 to 6. And now if we start changing the ranks, all of this should update accordingly. So we now should start on rank 4 is on page 1. And there we have it. It is working exactly as we intended. So finally, we have too many options available. Actually, we don't even have 20 pages worth of data. If I click on page 20, there's no data to display. And that's because we've stuck with the automated function, which is simply saying start at number 1, go up to number 20 in increments of 1. So, but we don't want to finish at 20. We want to end at the maximum number of pages we have available. And we have already calculated that with measure 2, the page number calculation. So if we make that the upper limit instead, and we see what that gives us, that is now correct for group alpha. We have 4 pages. And if I cycle through them, actually I'll remove this selection here so we can see all the items. Page 1, items 1 to 3, page 2, 4 to 6, page 3, 7 to 9, and page 4, the last item, number 10. So that's working for group A. But if we come here to group beta, and remember we have less items on group beta, there's no data for 4 pages. Actually, we should only have page 1 and 2. So this is where the last flag will come in to make this truly dynamic. And that flag will be done with another and the final measure. And we'll use the same technique of converting a true or false value into an integer, so a 1 or a 0. And we're simply saying that we only want to display numbers if they are inferior or equal to the maximum page number for that selection, which for beta is going to be 2. So if we take the flag and add it to the filter, or to the parameter I should say, and then we filter for that only when it matches our criteria, then just like that, let's make that a little bit smaller. We know that for group 2 or group beta, there's only 2 pages, 1 and 2. If I switch to group alpha, we now have our 4 pages. And there we have it. What we achieve now, tidying up things a little bit, is a dynamic slicer that will show you the number of pages you desire. It will respond to the selection of your data, in this case beta, or even if you change the amount of items you display, the page numbers will be updated, and it will also in turn control what you can see on the table, which is dependent on the maximum number of items you have. So if I now change this to 4 items, it will again recalculate the number of pages we have available. For beta and alpha, now we only have 3 pages. So there you have it. This concludes this short series of videos on building a Power BI report from start to finish, all the way from getting data to building the report front ends and then the data model. All the resources can be found on GitHub and the link is in the description below. I hope you found this useful. If you have any questions, feel free to ask in the comments or reach out to me directly on LinkedIn. I hope to see you soon.